Hey, this is Tobias. I'm here to talk about a new mental model you have to adopt when you implement continuous deployment. And it's this. When you first adopt continuous deployment, it's easy to assume your deployments are like traditional deployments and you just do them more frequently. But that's not true at all. With continuous deployment, every single change you merge to trunk gets immediately and automatically deployed to production. That means you have to rethink your deployment practices. In particular, you need to shift test automation left, reduce deployment time, and roll forward, not back. Let's start with test automation. One prerequisite for continuous deployment is that you have a deployment pipeline with an automated test suite, and that test suite should pick up any problems. But the deployment pipeline only runs when you merge a code change to trunk. So if you merge bad code and it breaks the pipeline, you're blocking both yourself and your whole team from making further changes until the problem is fixed. To address this, you need to run your automated tests before you merge your changes. And the best way to do that is to automatically start a build and test job whenever you create a pull request to trunk. If you do this, your test suite will complete in the background while human reviewers are looking at your code. Most popular source control tools can display test results right there in your pull request, so reviewers can approve a change with more confidence or help fix any test failures. And of course, you should block merges to trunk until all tests pass. Now, running tests on a pull request only makes sense if you have the right tests in place. So you should also commit your tests together with the code they cover. This allows other engineers to review them together in a single pull request and make an educated decision about whether your code has enough test coverage. Also, your tests will only be dependable if your test environment matches your production environment. So it's not just production that needs to match trunk, but all of your testing and staging environments as well. Next, you need to reduce deployment time as much as possible. When you merge a pull request to trunk, trunk will be out of sync with production until the change gets deployed. If deployments take a while, this creates a risk that other engineers will merge further changes without knowing the outcome of the first one. So to create a nice sequential flow of changes going to production, the deployment pipeline must be quick. How you achieve this depends on where you are today. You may need to scale up your build machines or parallelize your tests. You could break large services into smaller ones so each one is faster to build and test. You could even consider using languages like Go that build really fast. But since we just talked about shifting test automation left, here's my best suggestion. If you already run the full test automation suite when you create a pull request, you probably don't need to run it again in the deployment pipeline. Instead, handpick a small number of tests that exercise your core workflows and run only those. This will speed up your pipeline and still give you enough confidence to deploy to production. You're probably wondering how fast is fast enough. If your continuous deployment pipeline takes 15 minutes from merge to production deployment, you're in good shape. This is fast enough that engineers won't get bored and start working on other tasks while they're deploying, and you can easily complete 15 or 20 deployments in a day. If you can't achieve this, try to at least keep the pipeline under an hour. That way, you can still get 4 or 5 deployments done in a day, and engineers can keep an eye on their deployments while moving on to the next task. On to rollbacks. When you do big bang releases every few months, you're deploying a lot of code changes at once. That makes it hard to track down the root cause if something goes wrong. So as a safety net, you need the ability to roll back a deployment. This allows you to restore service and take your time on troubleshooting. But when you move to continuous deployment, you now deploy exactly one code change at a time. Each deployment is small, so it's much less likely to break something in production. And if it does, you know exactly what changed, so you can troubleshoot the problem in minutes. That means rollbacks are no longer needed. And that's not all. When you switch to continuous deployment, rollbacks are dangerous. If a deployment changes a database schema or service contract, rolling back may compound the problem or cause data loss. And if you roll back a deployment, the code in trunk no longer matches what's running in production. So if another engineer merges an unrelated change to trunk, that change will be deployed directly to production along with the broken code that was previously rolled back. This will break production again, and the engineer that deployed the latest change won't know why. Rollbacks in production violate the trunk equals production mentality, and this makes your deployment safety worse, not better. Okay, so what should you do instead? Always roll forward. If a code change breaks production, fix the issue and deploy the fix. The problem should be easy to find because each code change is so small. But if you can't identify the problem and you really need to roll back, then roll back in code. In other words, reverse the code change in trunk and let your deployment pipeline build and deploy trunk to production. This ensures trunk and production are always the same and makes it safe for engineers to commit their changes to trunk. If you took my advice to reduce deployment time as much as possible, rolling back in code will be fast. Alright, time for a quick recap. With continuous deployment, your deployment safety depends on making lots of small changes one at a time. For this to work, you should ensure the code in trunk matches what's deployed in production. Add test automation to your pull request process to ensure breaking changes don't make it into trunk and block your team. Optimize your pipeline for deployment speed so engineers are always making changes against the same code that's deployed to production. And never roll back deployments, because that leaves production out of sync with trunk. Roll forward instead, or if you must roll back a change, roll it back in trunk, then deploy it to production. Stay safe. Keep trunk and production in sync.